This is the first video for circular measure, and the first part of it is just a recap on what the relationship between radians and degrees. So we did this in IGCSE again, where we had made it that 180 degrees is equal to pi radians. And with that information, we can make any conversion. 0-degree conversion, 30-degree conversion, 45-degree conversion, and so on, right? I'm going to let this as an exercise, right? And you can get the answers in the notes worksheet, right? I mean, in the notes PDF. So I'm going to skip through this and go straight to the next one, which is new. So in IGCSE, whenever you were told to find the arc length, what you did was theta over 360 times the circumference, which was pi d at that time, right? And this was the formula of the arc length, where pi d was the entire circle. Then the proportion of the circle that you took, that's going to be the proportion that you multiplied by, which is given by the theta over 360. When it came to radians, the reason that conversion was done was to make this a lot easier. So that theta over 360 became theta over 2 pi, because remember 360 is just 2 pi, and remember pi d is just the same as 2 pi r. And so what that did was theta over 2 pi times 2 pi r, these just cancel out, and we ended up just getting theta r. So theta r became our arc length formula, where theta is in radians, right? And that's how we would find it. Example, we can do it right here. An arc subtends at an angle of pi over 3 radians. That means theta equals pi over 3. And at the center of a circle with radius 15. Find the length in the arc. So arc length will be equal to r theta, which is equal to 15 times pi over 3, which will give you 5 pi. Yeah? And that's going to be the arc length in terms of pi. Second one, the sector has an angle of 1.5 radians and an arc length of 12 centimeters. Find the radius of the sector. So this is now a bit different. You have the arc length now, which is 12, equals to r theta. You don't know the r, and you know that this is 1.5 over 1.5 over 1.5. And you end up getting r equals to 8. And that's how you use the formula to answer the arc length question. This is probably one of the easiest sections. There is some stuff which we'll see in the next example that we do need for this as well, which we did learn in IGCSE. And yeah, we'll see it here. So example 3, arc length. Triangle ABC is isosceles, meaning these two are the same, which means this is 0.9 radians as well. Where AC, CB are both 8. CD is an arc of a circle. Center is B. That means this 8 is the radius. And the angle is, the theta is 0.9. Find the length of the arc CD. So remember, arc length is just equal to r theta, which is just equal to 8 times 0.9, which is going to be 7.2 centimeters. That's going to be your arc length. Then you want to find the length AD. Now, to find this length right here, we need to think about it in the larger shape that is there. So if you see, this is in no way related to the sector that we have, apart from the fact that we can compare it with this one, which is also 8 centimeters because it's also the radius. And if we find AB, we can subtract it by 8 to get AD. But we have to look at the triangle as a whole for this one, right? Which is where the stuff from IGCSE comes in. 8, 8, 0.9, and this whole thing is what you are interested in. And this is a perfect example of the cosine rule, where c square equals to a square plus b square minus 2ab cos c, where c and c are opposite to each other. The capital C being the angle and the small c being the side opposite that angle. So this ends up becoming 8 square equals to 8 square plus b square, which you're finding here, minus 2 8b cos 0.9. And this one, obviously these cancel out. We end up getting 16b cos 0.9 sorry, b square minus 16b cos 0.9 equals 0, because you just, yeah, write this down as it is. Then this right here is going to be b squared minus 9.94576 b equals to 0. Then to find what b is, you can factor out. So b minus 9.94576 equals 0. That means b equals 0 or b equals 9.94576. And obviously b cannot be 0 because it has a length, as we can see. Therefore, we take b as this right here. So this whole thing is 9.94576. And if this whole thing is 9.94576, what will AD be? We'll subtract it by 8. And if we subtract 8 to that, we will get 1.945759. And the perimeter of the shaded region, which is this side right here, plus this side right here, plus the arc length. So you have 8 plus 7.2, which we got in A, plus the answer we got in B, which is 1.9. And we add that all up, and we get the perimeter of the shaded region.